This is Nazeer from the Faculty of Civil Engineering Technology. Welcome to all of you to Algebra and Trig 1. This is starting of Chapter 1-2, Fundamental Operation of Algebra. And of course, we're going to deal with some definitions, commutative and associative. Commutative law of addition is the sum of two numbers. The sum of two numbers is the same regardless of the order the numbers are added in. When we look at this, we have two numbers, 2 and 5. You add them, you get 7, or 5 and 2 is 7. So it's just telling you that the two numbers, the order doesn't matter, the result, the sum of it will be the same. Associative law of addition, when we look at this one, the sum of 3 or more numbers. So now we've gone from 2 numbers to 3 or more numbers. The sum of the is the same regardless of the order the numbers are added in. So we have 3 numbers here. We have 2 and 5 plus 10, right? So when we add these up, we have 17. When we look at switching the order around, we could go and add 10 plus 5, 15 plus 2 is 17 again. So it doesn't make a difference. You just have to know commutative is 2, associative is 3 or more. When we look at commutative and associative law, there's commutative and associative law of multiplication also. So we're going to look at that right away. Commutative law of multiplication, the product of two numbers is the same regardless in what order the numbers are multiplied in. So when we look at this, 2 times 5 is 10, right there, and 5 times 2 is 10. The order again, commutative, 2. When we look at associative law of multiplication, the product of 3 or more numbers is the same regardless of the order the numbers are multiplied in, right? So we have 3 numbers. If we were to go 2 times 5 is 10, times 10 is 100, right there. And if we switch that around, we take the 10 out front, 10 times 5 is 50, times 2 is still 100. So that is commutative and associative law of addition and multiplication. So that's what the terminology really means. When we look at the distributive law, which is more commonly used in algebra, and we are looking at the A on the outside of the grouping bracket, and it's going to be distributed to each one of the terms on the inside, right? So when we look at this, A, B, when you multiply that out, and that gives you the first term. And then we have A, C, which will give you the second term. So you're multiplying these out. When you look at this, this is called factored form because the last mathematical operation is a multiplication. You have to do what's in the grouping first, then you multiply, right? But when you distribute it, it becomes the expanded form of that factored form. When we look at the second example that I have here, very simple examples, but they illustrate very well. We have the multiplier or the factor on the outside of 3, and 3 times x will give you 3x, and 3 times 8 will give you 24. So that's the distributive law. We will deal with these things more detail in other chapters, but it's important that we start at a low level and we progress all together at the same level to the more difficult material. When we look at this one here, this is dealing with the distributive law still, and we are looking at factored form because we have to do what's in the grouping brackets first, and then the multiplication is understood there. You're going to multiply that. So this gives it the format of a factored form. Now if we were to go and use the distributive law and make these into all terms, then we would have the expanded form, right? So we're going to multiply each one of these terms with each one of these terms. So y times y will give you y squared, and y times 4 will give you 4y, and minus 3 times y will give you minus 3y, and minus 3 times 4 will give you minus 12. These are like terms. The simple reason for them being like terms, the coefficient, it doesn't make a difference with those, but the variable itself is the same, and it has the same power to it. There's an understood 1 there. So these become like terms. When we look at this, we're taking positive 4y minus 3y will give you positive y, and the rest of this stays the same. So this is now the expanded form of the factored form that we have up here, right? When we look at the second example that I have here, we have a trinomial, and it's multiplied by 6x. It's factored form. I'm going to multiply this out and then look for like terms to put it in prime form. 6x times x squared will give you 6x cubed right there. 6x times minus x will give you minus 6x squared. And then we are looking at 6 times 3 is 18x right there. When we look at this now, remember that with like terms, you have to have the same power. All of these powers are different. So we have it in its prime form. You put it in descending power. 3, 2, 1. You leave it in descending power. Okay? When we look at the summary of what we the last 4 slides or so that we went through, we have commutative law of addition. No matter the order, you're going to be equaling, you're going to have the same sum, right? Associative law, 3 or more numbers, no matter the order, you're going to have the same sum. Commutative law of multiplication, no matter the order of the 2 numbers, you're going to have the same product. And associative law of multiplication, when we look at this, we could add what these are and multiply it by A or C, you're going to get the same product. Distributive law. When we look at this, we are distributing this to each one of those. This factored form is equal to that expanded form. When we say it's equal to, we're talking about the value. If you plug in values for A, B, and C, you will find that each side will equal each other. The value doesn't change, but the form changes. Order of operation. The order of operation, order within specific groups. So you go and use groups. Groups are usually brackets, or you're doing a radical sign or something like that, but generally it's brackets. You do that first. Power or exponents are done second. Usually the term exponents is used for this. Perform multiplication and division third, and addition and subtraction is done last. So these are the order of your mathematical operation. You're going to go group, exponent, multiplication, division, addition, and subtraction from left to right or so. Operation with specific groups are done first. This is the same thing, but it's just a slightly different format. Again, these are brackets. Specific groups are brackets. Perform multiplication and division, addition, and subtraction. Well, they skip the power exponent right in here, right? So it's still valid, but it's there. When we look at an acronym now, this acronym BEDMAS, it is a word association that allows you to figure out the order of operation. It says brackets, exponents, division, multiplication, addition, subtraction. Again, brackets, exponent, division, multiplication, addition, and subtraction. I know that in normal situation you go multiplication and division. It doesn't make a difference if these two terminologies are switched around. When we look at some example or operation with zeros, when we look at operation with zeros, we are looking at if you take a number and add it to 0, you don't change the number. If you subtract 0 from a number, you do not change the number. However, if you multiply anything by 0, you get 0. If you multiply anything by 0, you get 0. And if you divide a number into 0, you will still get 0. So these are important rules of 0 that we have to remember. The last one that we have here is any number divided by 0. Any number divided by 0 will be undefined, because 0 could go into any number basically an infinite number of times. And of course, you have to keep that in mind, that you will not get a result from this. Even if you punch this into your calculator, you will see that it comes up more than likely with an error. When we look at this operation that we have here, they have several different things that are happening here. First we have the grouping, we have the power. Within the grouping we have a radical sign, and then we have all of this minus from 14. So when we look in, we have to work within the groups first. When we go inside of the group, we see that we almost have a second grouping bracket, which is the radical sign. So I have to do the denominator and then divide that, take the root of that, divide that, square it, and then subtract it. The last thing that I'm doing is subtracting from 14. Right? That's the last thing that I do. And again, when we look at this, this is 14 divided into 3, taking the root of that, you'll get this number here. Right? When I divide this into 2 and square it, I get 18.67. You could run this on your calculator. And then I subtract 18.67 from 14, you'll get 4.67. So those are the order of operation. If we're looking at, again, we went into the grouping and did that first. We went to the exponent, did that. There was no multiplication or division, but we had a subtraction, and we did that last. Okay? Let's go to this example. We have really two terms here. Terms are separated by minus and plus signs. So we have two terms. This is one term and this is another term. And we are going to perform the mathematical operation of these terms. When we look at this, the numerator of the first term, we can't do anything to minus 12. The denominator, however, we could do an operation there. We'll end up with minus 6. So we have minus 12 stays the same, minus 6 is right there. When we look at the numerator of the second term, we could take away 1 from 5 and get 4. We are multiplying here. Multiplying by minus 1 just changes the sign of the 2, so we have that. We're going to go and basically perform the division here first. Multiplication and division before addition and subtraction. The addition and subtraction is right there. So anything divided, minus divided by minus will give you a positive. So you get a positive 2 right there. And minus 2 into 4 will give you a minus 2. So we are ending up with the addition of these. Positive 2 minus 2 will give you 0. Okay, so then we're going to go to the next one now. This one, a little bit more, might stump some people, but if you follow the order of operation, you'll get it correct. We know that multiplication and division before addition and subtraction. So we have to do this part first. We have to do this. When we divide this, we get 2. So when we look at this, 20 stays the same. We divide this out, we get 2. 20 plus 2 is 22. Now if we were to go and do it the other way, we would be totally incorrect in the first place, but let's go and see what the number is. We have 28 divided by 4 will give you 7. So that answer would be 7, which is way different than 22. Right? So let's go to the next one. We have 7 minus 7 divided by 5 minus 7. Right off the bat, because this is the numerator here. This is the numerator, this is the denominator, this is 0. Anything divided into 0 will give you 0. So when we subtract the numerator, we get 0. And when we subtract this, we get minus 2. And of course, anything divided into 0 will give you 0. Alright, let's go to the next one. This one I see that we have right there 3 minus signs. So I know that I'm going to come out with a minus number for these guys here. Right? And then I'm going to minus a 10. So this plus sign will disappear. When we look at this, we have a multiplication right here. 6 is 48. It'll become positive 48. A minus in front of it, minus 48 right there. And because this is a minus in front of there, and then we add the 2, minus 48, minus 10, minus 58. Right? So that's another order of operation. When we look at this, we are looking at absolute value brackets in the numerator right here. We're looking at absolute value brackets. Whatever happens within the absolute value brackets, whether it's minus or plus, it stays plus. But when we have a minus in front of that absolute value bracket, it changes back to a minus. So we have really plus 5 and a minus outside of the absolute value brackets, it becomes minus 5. So that's where I got that. The 7 stays the same for now. when we look at the denominator, when you multiply a negative by a negative, it becomes a positive. Minus 1 times minus 2 will give you plus 2. I'm going to go and subtract these guys here. 5 from 7 will give you 2, divided by 2 will give you 1. Alright? When we look at the second example now, we are looking at 20 minus times minus 12, minus 40 times minus 15. So I know that this part is going to become a plus, this part is going to become a minus. Now, when we look at 20 times 12, 12 times 10 is 120, 240, minus 240, right there, right? And we know that this is going to become a plus, so we have 400, 600 there, plus 600 right there. When we look at the denominator, we know that this is a positive because it's in absolute value brackets, but it has a minus in front of it, so it becomes a minus, it becomes 98 minus 98, right? Which gives you 0. Anything divided by 0 is undefined, right? Undefined term. It means that 0 could go into that number an infinite number of times. Really, it's not a valid number. It goes into the area of imaginary numbers. Okay, and that's all for this section. You need to do your homework on this section, and if you need to, do some more work on these pages at the end of the section. Thank you very much. See you for the next one.